Okay, I want to do this quick recording again. So we plan to meet today, but I could not see you. So I'll just do this quick video. Let me share my screen so that we'll be able to see all the other ones. Um, let's let me share now. I want to share my screen. I've started the R video and uh, I'm sharing the screen now. So I just want to see. Uh, Now I'm sharing my screen and I'm using the richdata.r. I want to see how we can go through this. So with this file, you can put your own data here. So the first thing, as I normally say, is make sure you get your working directory. Okay, this is the current working directory, which is you can see it here, which is not where my data is located, the same thing. So I have to do the set directory. And then this is where the data is located now. User, PC, desktop, our workshop, ABU, DSW. So we click on this. I want to read the data. This is daily.csv with the header. As I said, I can equally put your research data here. The same thing, the data you have worked on, you can put it here. Now, so now it has been able to read the daily.csv file into my data. So this is my data now. This is the content of my data. And you can see the header. You can see physics, chemistry, English, maths, literature, economics, the tribe, the gender, the location, the residency, uh, the age and the SC and level. You need to know each of the variable and what it stands for. And if you just want to get the header, you only use the header to take the first 1 to 6. You want to get the dimension of your data. This is 50 row by 13 column. That means you have 15 occurrences and you have 13 variables. So these are the things you need to get properly settled with your hope my audio is going on. So this is what we need to get properly settled. So it's very important to get this properly settled. I'm trying to be sure whether my voice is audible. Now, from here, these are the things we can do. Don't forget, on any data you're working on, the basic things are data cleaning, data subsetting, normalization, exploration, visualization, comparison, analysis, data modeling, then model interpretation. Then you can now do some programming with functions on your data. So let's get data cleaning. We're trying to get the first 6 row of my data, the subject. That is, the first 6 column. When you see comma here, it means all the rows will be selected. But if you put a number for column, for row here, to select that number. For instance, if I put 6, or if I put 1 to 10 to select 1 to 10 row, before I put this first comma. That's for the row. Anything after the first comma is referring to the column. So the columns are the variables, the headers. Okay. So let me run that. Then I'll pick the subject. So these are the subject that has been stored there. So I can do the summary of the subjects. These are the summary. You can see them. We'll find time to explain some of the things. This is for subject 1. This is for subject 2. And then like that, you can pick them. You can do combine of subject 1 and subject 2. So there's a combo, and we can see the 2, physics and English, and then 2 and 4, physics and English. First one is physics and English. So let's look at the next one is physics, chemistry, and maths. Then for COM 3, 5, and 6, this is let's see what is in COM 3, that is literature and English. So it's trying to combine them. So this is the uh, uh, this is the yeah. So you can see this is what is there now. Because this is what is stored in COM 3. So we can pick the first 30 data, then we can look at it. You can see that's the first 30 row of its occurrences. Now we can also say 30 data, and that 30 rows and 6 columns. So this is what we have done here. We can display it also. You can see that. So we can apply this for the mean, and apply this for 2 is for the column, 1 is for the row. Okay. Then this is for the median. This is for standard deviation. This is for the variance. This is the head of my data. You can do the correlation of the subjects that we have already gotten up there. These are the correlation of the subjects, physics, chemistry, English, and this is how they are correlated. Now, you want to pick other things. You can pick the column 1, 2, 3, 4, 5, 6, then 11. If you check that column 11, you will see that is another, okay, let me quickly open it so that you can see. You can see this should be column 11. Sorry, let me go back to my data. Okay, this is my data. Okay, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is SH, that is column 11. So that's then you can see. So want to see what is happening here. We can run. So you can see with all this with SH. Then you can see the pair. Take them. You can see if you are seeing the whole of the. Let me see whether I can stop sharing and then maybe share. Let me share the active. Okay. Yes. So I'm sharing this. Okay. So you can see this is the output of that. We can close this. So let me share again. Yeah. Let me go back to the main sharing. Okay. So you can just experiment with this. I don't want this video to be too long so that it won't be too heavy. These are things you can do on your own. But you can put your data there and experiment. So the important thing is being able to clean your data, subset, and then you can also adjust. Then you can also do some analysis So this is the sub. This is the mean average for physics. This is the average for chemistry. Then we can plot this. Okay. You're not seeing my plot. Just try to open. Just try to experiment. You will see the kind of plot that you see there. Another one you see all the plotting here. You see them. It's we can also plot this one can be plotted. When you plot, you may not go and look for the. Yes, this is blocking me here. And so I have to probably shift this. This is the plotting here. And this is a correlation here. This is the correlation. Then box plot, plot subjects. You can see, you can take this one up so that you can see the box plot. You can see the box plot here. Okay, let me see if I can stop sharing the screen. Okay, this is what I'm sharing now. I want to stop the share. I want to share a new one. Okay, I'm trying to share the bus plot. Okay. Yes, so I'm trying to share this. You can see what I'm sharing now. So this one can be shared. So you can see this is the bus plot. You can always pick it from there. So I share back my studio, and then so just go through all these in read data, and you'll try to make sure all these ones are installed. If they have not been installed, install them. If they have been installed, you just load them. These are for the beautiful plots. This is color Birua. This is a correlation plot. I think we have installed that before. If you try to load the library and it did not give you error, that means it has been installed before. But if you try to load it and it says uninstalled, then you have to go back and install the package. So we can now do the correlation here. When you check the correlation, you will see this is correlation. So let's now plot the correlation data. You can see this is the correlation data. Let me try to stop the share. Let me share the new correlation screen. Okay, this is it. Can you see this is the correlation screen now? Yes. So this is the correlation screen. This correlation screen now. So let me stop it so that I can finish on time. I'll go back to my RStudio screen. I believe you're seeing that now. So the same thing you can do with every other one. Then the other one is regression. We normally use LM, linear model, for regression. So we normally also talk about regression as fitting. So that's why you can use the variable name or assignment name fit one. So want to see the regression between maths and SH. We're picking the data subject one. So this subject one is what we have created here. 1:1, 2, 3, 4, 5, 6, 7. So you have to run it. If we don't run it, it will not be stored in subject one. So we want to know what is subject one. This is what is happening here, whether we are trying to see how the model fit between the physics, chemistry, English, math, literature, economics, and the tribe of the students that got the marks that we see here. So, so let's see. We have already displayed the subject, so we can now do the fitting. When you're doing the fitting, you have to type the keyword LM. LM is the regression linear model. Then when you see maths, then you use this word sign tilde. And then so we're now doing maths and the this is maths and SH. Okay. The data is subject one. So let's look at that. Okay, fit one, not so we have not done. Let me see fit one. Error. Yes. Okay, okay. Now you can see the problem here is that in the subject one, supposed to be tribe. Supposed to be tribe. So it's not supposed to be tribe. Okay. So let's try it again. Aha, you can see it worked now. Because that data, subject one, does not have SH, it has only tribe. So if we had included the SH in subject one, then you'll have seen it. So let's look at this. This is a summary of this. This is where we get our T value. We have the probability value. We know just to be anyone that you see that is 3, that means is very, very significant. Then you know that the proper significant value is less than 0.05. Then you see all this thing here. So this one will be interpreted later. We'll talk about interpretation later. And then you have this. Then you have you can see this one is subject referring to everything. So we want to now see the fitting. Okay. It's trying to fit all of them. That means all the subjects, not the subject one that we pick. Want to see the gender. The gender factor is not okay, that means the factor gender is not there. So I have to go back and define our gender, see whether there is any gender there. If you go back to my data, you will see that gender is here. So we're supposed to find why is not working there. Let me save this thing so that this can be troubleshooted. And see your troubleshoot so that we know why this gender is going to. So this is we're supposed to pick it from the data set. So that's a problem. I can solve that. You can see some of these things cannot because of the mistake that have been made in the subject. So okay, you can see data is supposed to be subject, not subject one. Okay, so let's do it. Okay, it was not done there. I think that should be my data. Sorry. This was supposed to be my data because that is actually where we have all the data. So let's try this. So it's try to get that, but there will be a problem with the other, because there are strings in that. So you have to be, it's going to try to do it, but you're going to have some error. We can do coefficients. So the coefficients of all those that are available. Then we can plot our feet. You can see the plotting of the feet. It may take some time. And then if there's an error, it's not going to finish on time. So we can just terminate it. Okay. Because if there's error of string that cannot be plotted, it will take time. So here I'm going to stop because of the time that I don't want to waste much time here. Forget, let me see. I hope I'm still, so I'm not recording again. Thought I'm recording. Okay, I'm recording, but the timing is not showing. Okay, no problem. I will see what can we do. So let me share the screen and see what I'm still sharing. Okay. Um, yes, I need to probably minimize this. So here we can do all this. Then we can do, as I said in the first one, you can do Shapiro tests. If I've not done this, we can do all this thing. One can do normality tests. This is what we normally call exposure analysis with graphs. We can do Shapiro tests. When you do the Shapiro tests, you want to check whether there is any uh, let's see this, okay. Let's see the test here. All these tests, then we can store them and then we can get the value out. So you can see all the uh, uh, what we're supposed to do. Let me see, we can do T is equal to this. Let me do this first. And then let's put the T so that it can be displayed. Okay. That's one sample T test. Same thing with this. Uh, Same thing with this. But we're supposed to be able to see the output. Maybe we'll try to solve that next time. Then we can do general linear regression. This is a chi-square test. We have to do categorical data. You pick the aggregate data for this. And then you can do all this. And we just experiment with all the other ones. So I'm going to stop here because of the time. When we're doing principal component analysis, we can install more packages. So I will try to resolve some of this problem. So let's stop here. I want to stop the sharing. I want to stop the recording.